Hello everyone. I'm gonna give 5 minutes for everyone to join. If you can hear me, can you just type in the chat so that I know um, that you can hear me? Is it better now? Uh, can you hear me now? Let me know if my voice is better now. Okay, nice. Okay, I guess we'll wait for 3 more minutes and then get started. Um, yep, so I'll wait till 10:05 and yep, because I guess it's early morning for some parts of the world, so everyone's just gonna be waking up or like in a sleepy mood. That's why we don't get a lot of people on live stream. Um, yeah, we'll just wait for 3 minutes and then we'll get started. Will I get a job after this? Um, After doing LearnWeb3 DAO, I guess you'll get enough skills that if you do the levels like nicely, not like like you understand what's going on. If you do them with dedication, obviously you'll understand things and you'll be better at Web3 programming. So your chances of getting hired is definitely increase because I work at a Web3 company and I know that the skills that we are teaching you are something that we use um, as a Web3 programmer in our day-to-day life. So um, they're definitely gonna help you in getting a job, but obviously it's not a guarantee because ultimately it's up to you to go to the interview to do the levels with dedication. So, but yes, there's definitely a higher chance of getting a job if you do all the levels with dedication and hard work and like understand what's going on in the levels and not just copy paste the code. You definitely have a higher chance. Um, I mean, you can also get a job after freshman. Like many of our students, like some of our students got a job just after freshman. Um, and I guess they got it because after completing freshman, they started working on side projects and started building their own stuff and started applying those skills that they learned during freshman to their own projects and started applying for hackathons. And yeah, they started getting so many job offers and so many gigs just by doing freshman. So it's more about your dedication, your effort, than it's about whether the course would get me a job or not. These are the skills that are required, but you need to put effort into it. Which company do I work at? I'm currently not. I'm just working on LearnWeb3 DAO, but I was working at Coinbase previously. But yeah, and I would think of same. LearnWeb3 is a guidance to your journey. Yeah, you still have to like polish your skills to be able to get a job, but you still would be equipped with all the tools to get it. That's what I would say. We have given you all the tools, all the pathway to become a Web3 developer. You just need to follow it with dedication and hard work, I would say. When I was like starting in Web3, there was no roadmap on learning all this stuff, and it was very hard for me to understand what's going on. Like, for example, one of the tutorials on graph, I remember when I was, I guess, like the time when I started Web3, graph was so new that like the CEO of Graph was like sitting next to me and debugging what's going wrong in my code when I was trying to implement the graph for first time. And we won a prize at ETH New York for implementing the graph. And very few people at that time were actually using it. So yeah, like now you have everything. There's so many tutorials out there that you can learn and do everything, and you don't need the CEO of Graph to sit next to you and help you debug your code. So we are at a good stage in Web3 where you have so many resources. You just need to use it now. That's what I would say. All right. I think it's 10:08. Okay. Oh, we're 10 minutes late, but let's get started. So today we're going to learn one of the biggest buzzwords in the entire world right now. I think the second biggest after COVID, for sure. NFT. So NFTs are one of the most like commonly talked about topics these days, and everybody wants to drop their NFT collections. They want to own an NFT, and NFTs are going to play a huge role in the world in the upcoming, I guess, time. It's going to play a very big role. So we're going to learn how to drop our own NFT collection today. One of the prerequisites is that you have completed the whitelist DApp tutorial. This is the one we also created a YouTube tutorial on. Yes. Okay, there's some issues here. The links are not here, but yeah, we have a video for this tutorial on. Oh, okay, my internet is just behaving slow. Never mind. Yeah, we have videos for whitelist DApp that you can watch and learn about it. But today we'll learn about NFT collection, which is like the second part. So we're going to in the first part we learned how to create a whitelist for the NFT collection, and now creating our NFT contract. This is we briefly introduced how to make NFTs in the freshman track, but there we didn't teach about a lot of stuff like metadata, etc. So that's why I guess it's time for us to um, like get a little bit deeper in what NFTs are and how they work. Okay, awesome. So requirements. So we're going to build something like this. So it's going to be a website. There's going to be a place where you can mint your NFTs, and it's the name of the NFT collection is called Crypto Devs, because we're all developers in crypto. Yeah, so there should only exist 20 crypto dev NFTs. That's the limit we are introducing. One user should only be able to mint one NFT with one transaction. So when someone sends one transaction, they should only be able to mint one NFT. Whitelisted users should have a 5-minute pre-sale period before the actual sale, where they are guaranteed one NFT per transaction. So what this means is, like, according to the whitelist app tutorial, you might have like already whitelisted some addresses. And those addresses would get a 5-minute pre-sale period, which the general public won't get. And during this 5-minute pre-sale period, they're guaranteed one NFT per transaction. So for every transaction they do, they're guaranteed one NFT, because everybody's not gonna just keep interacting with the smart contract. So you need to build a website. Awesome. Okay. Then we gave a brief introduction on what non-fungible token is. Oh, by the way, actually, I should drop this link here. This is the link for our GitHub. If you want to go and follow me, you can also go here and you can follow us. All right, so non-fungible tokens. Non-fungible tokens are ones which cannot be broken or cannot be split into multiple parts. They're just one as a whole. Like ETH, for example, you can have 0.1 ETH, 0.2 ETH, 0.3 ETH, and so on. But one NFT is just like one NFT. You can't have like half an NFT. So that means it's non-fungible. And NFTs are essentially a way for identifying something, like like NFTs can be unique, but that's not always true. They can also be like, if you learn about ERC-721, there can be like duplicate NFTs as well, but we'll not go into that right now. What we are going to make is a collection of 20 unique NFTs, and each NFT is going to have its own metadata. Metadata is basically the properties that are associated to a given NFT. And we'll build that. NFTs are usually used for things like unique art, for gaming characters, for anything that's unique. You can use NFTs for. You can also use NFTs for tickets to concerts. In that case, I guess it would be same NFTs which are like melted with NFTs which have the same metadata. They follow a standard called as ERC-721. But yeah, that's not what we're doing here today. But you can also have NFTs as tickets. You can have NFTs as, for certificates. So for example, if you go to our NFT collection, like LearnWeb3 DAO's NFT collection, that's in ERC-721, meaning that every student gets the same NFT. So if you're a freshman graduate, every freshman graduate gets the same NFT. So yeah, they can be used with for certificates as well. And I feel like certificates is going to play a major role in how they help us in the future, because people are building on-chain reputation, on-chain resumes, all these things that are coming up with NFTs. So they're not a scam. They have a huge, huge role to play in how our future turns out. All right. And the standard that we're going to follow is called as ERC-721. So what is ERC-721? Um, ERC-721 is a Ethereum standard, and I guess you can also read it about here. Yep. So it's an EIP non-fungible token standard and a standard interface for non-fungible tokens. So this is like an interface that you can use. And if you use this interface, it's going to be like compatible with lots of marketplaces like OpenSea and LooksRare and other platforms that are using this standard. So it's better to follow this standard because you will be compatible with other marketplaces and other platforms that are using this standard. So that's why it's important for us to use this standard, because it's one of the standards that has been introduced for non-fungible tokens. You can also read about other standards here in Ethereum improvements proposals. You can also submit a proposal, lots of things you can do here. But yeah, we're going to use the ones related to see, like there's so many proposals here, but we're going to use the one for non-fungible token standard because that's what we're building. All right. Okay. Second thing that we're going to be using is something called as Ownable.sol. And Ownable.sol is again a standard for maintaining ownership. I'm not sure if I can find here. Yep, okay. All right, so yep. So this is one of the standards for ownership. And like you see, there is a function called as owner, transfer ownership. So this contract is simply used for the ownership of smart contracts. And again, this is a standard. So if you use it, you'll be compatible with other marketplaces and other platforms that are using this standard. So it's better to use standards so that you're compatible with what everyone else is also using. And I guess you can read about it in OpenZeppelin's repository. They provide you with all the functions that are there. So like, for example, this one that we were looking at, they have added some of their own, like renounce ownership, transfer ownership, all these functions that we will use for maintaining the ownership of our smart contract. Again, this is a standard, and this is what is recommended you use in the industry so that you're compatible with other platforms. You can find all the other contracts in OpenZeppelin's GitHub repository. The link is here. Yep, but again, and transfer ownership is used to transfer the ownership of the smart contract from one account to another. And renounce ownership is when you want the smart contract to have no owner. So you want the owner to be a null address. This is done so that the smart contract is actually truly decentralized and no single address is controlling the smart contract. And that's what you use renounce ownership for. All right. So we learned about what ERC-721 is. It's a standard for non-fungible tokens. And now we'll use something called as the extension of ERC-721. So if you go to contracts and you go to token, you go to ERC-721, there's something called as, so this is the base ERC-721. So it gives you all the base functions present in the ERC-721 standard. But we want an extension of this because it doesn't have all the features that we need. So we'll be using something called as ERC-721 Enumerable. That's one of the extensions. Extensions basically means that it has more functions along with ERC-721. So it is inheriting ERC-721, but it's also adding some more functions. So some of the functions adding is total supply. So it returns the total amount of tokens stored by the contract. So it means like the total number of NFTs that have been that are being managed by the contract. Then it has the token of owner by index. Um, so it basically means that the owner is going to have multiple NFTs. So at a given address, it's going to return the token ID. So token ID is a unique identifier for a given NFT. So it's going to let us know if the owner has that token ID. Yeah, and this is basically token by indexes, just like this contract stores a list of all the tokens. So you're basically providing us with, you're giving us the index, and this returns you the token ID at that given index for all the tokens that are stored in the smart contract. So these three functions it's adding, and yeah, so we need these three functions. So that's why we're gonna use it. We don't need it in this tutorial, we need it in the tutorials down the lane, but we'll keep everything that we have to do down the lane in mind right now, and implement our smart contract like that. All right, so just remember that what this is, and like we are importing it. We'll explain why we're using this in the next tutorial when we actually use it. All right, but yeah, so we are going to use this. So basically, it keeps track of all the token IDs in the contract, and also the token IDs held by an address. So as we learned, held by an address is the token of owner by index. So it tells you the token ID owned by the owner at a given index, right? And the second thing, it was like keep track of all the token IDs. We saw that it keeps track of the total supplies, and it also keeps track of an array, and you can get the token ID by providing the index in that in the list that it maintains. I'm not exactly sure if it maintains a list or a mapping. Okay, yeah, no, it maintains a list of all tokens, but for own tokens, it maintains a mapping, and own tokens by index, it also maintains a mapping. All right, so but yeah, on the surface level, that's what it does. We'll learn about this in the next tutorial, so don't worry if you don't completely understand this. We'll do that. All right, so now it's something that we have all done in the whitelist tutorial as well. So we're going to use these commands to execute to create a Hardhat repository. Hardhat is it's an Ethereum development environment. It's like an IDE for development of smart contracts, and it's very fast. It's better than Truffle, so that's what we recommend using in our tutorials, because Truffle is something that was used when I was learning blockchain back then 3-4 years ago, and it's not recommended anymore because I guess it's not that widely used as Hardhat now. So I would recommend using Hardhat because it is much more faster and it has much more functionality than just using Truffle. So we'll use Hardhat today. Nice. Okay, awesome. Let's get started. So open up your terminals. So I guess terminals for Mac users and command line for Windows users. Don't use PowerShell because PowerShell is not compatible with Hardhat. So for Windows users, you need to use command line. And yep, I'm going to be using iTerm, but you can use whatever you want. But for Windows, you need a command line, CMD. All right, so I'm not going to do any black magic here. I'm just going to follow these instructions. These instructions are provided to you by Hardhat documentation. So if you go to their documentation, this is what they ask you to do. So this is what we're going to do. So I'm going to go to my desktop and I'm going to make a directory called as NFT-Collection. This is where I'm going to like store my code. Awesome. And now inside this repository, I'm going to create a Hardhat tutorial folder. And npm, I'm going to initialize npm, and the last step is saving the Hardhat. I cleared my terminal. Sorry, yeah, my internet is behaving a little bit slow. I'm sorry for that. Yeah, I really can't do anything about it. I guess there's nothing we can do. But yeah, it's just like internet problems. Even though I live in Canada, I don't understand why we can't get high quality internet. All right. So after you've installed Hardhat, the next step would be to run this command called as npx hardhat. And what this command basically does is it sets up the basic repositories that Hardhat wants. So it builds the entire folder structure that we're going to be using in our tutorial today. So just do that and then press enter for all these answers. And then it's going to install all these dependencies for you automatically. So you don't have to like set up folders, you don't have to like set up, you don't have to like manually install these dependencies. It does everything for you just by like if you just do npx hardhat. So Aku is, let me look at some questions. So someone is asking, can you show how to reduce the price for people who are whitelisted? Sure, yeah, I can show that when we come to the smart contract part. Okay. Still installing. My computer is acting slow today. Issues you have when you're programming live. Nice. But it did some stuff for me. Oh, shit. Okay. So it did some stuff for me, and I think my project is created, so that's good. And now what I'm going to do is I'm going to open this on IDE. I'm going to be using VS Code, but you can use whatever you want. But like you can use Sublime or Atom or anything that you like. But I'm just going to use VS Code because I have everything set up inside this. Do you have any questions? No? Okay. Nice. Alright, so now comes the fun part. We have all the folders. You can see like Hardhat gave you all the folder structure, everything. And now you can basically start programming. I think before we start programming, we also need to install some more dependencies. Also, yeah, if you're on Windows, you need to manually install these commands because for some reason Hardhat doesn't do this for you. It has some issues with Windows. So go ahead and install this if you're not on a Mac. you need to install this manually. All right. So as I was talking about, we're going to be using OpenZeppelin's smart contracts. These contracts that I was talking about and showing you the code for, we need to install an npm package for that to use all the contracts that they're providing. So that's why copy this and paste it and execute this inside your Hardhat tutorial folder. This is the last dependency, and then we can actually start programming our code. So people are saying there's interruption. Okay, I don't really know how. Is it still lagging, or are you guys okay now? I'm not getting any replies, so I guess I'm gonna continue. All right. So now we're gonna be like creating an interface. So this interface would be used to interact with the whitelist smart contract that we created last time. And how we do this is, why are we using interface, and why are we not just writing the code, just copy pasting the code that was given to us? Well, because we don't want to use all the functions that are there in the whitelist contract. We only want to use and check. We only want to use the function that returns us whether the address is in the whitelist or not. We don't care about whatever else that whitelist contract is doing. We only want to check if the given address, if the address is in the whitelist or not. So that's why when we deploy the smart contract, we don't want to waste gas. The more the length of the smart contract, the higher gas you have to pay. So that's why to prevent paying more gas, we create this interface so that we don't have to pay all the gas and we only pay for the things that we are actually using. So we're going to say SPDX license D for all right. So this interface only has this function, which is the whitelisted address external view bool returns. And how we got this function is that if you look at our whitelist contract, let's look at how we did our whitelist. So if you look at a whitelist DApp, and if you look at our contracts, actually let me show you the if you look at our whitelist.sol, there's this mapping called as whitelisted addresses, and this is because this is public, you can call this as a function, and it takes in an address and returns you whether a given address is in the whitelist or not. So it returns a boolean. So that's what we have implemented here. We have taken it's going to take in an address and it's going to return us a boolean. You can also see this in our ABI. If you go to our constants and if you look at our ABI, it tells you that it's a function, it's a view function, and it outputs, here it says uint8, but, oh sorry, this is number of our, oh here, sorry. So this is the whitelisted addresses. So this is a function, this is a view function. It returns the output is of the form boolean and the name is whitelisted address. So this is a type function with a view state and the type is boolean and the name is whitelisted addresses. So that's what we did here, and we created an interface because we only want this function. We don't want all the other functions that are there, like max whitelisted addresses, add address to whitelist. So we don't need to add an address to whitelist. We only want to check if our address is in whitelist or not. So that's why we only need this function. Okay. Sorry. Okay, I zoomed in. Sorry about this. Yep. So I hope you guys can see better now. If you have any questions, please let me know. So that's how you create an interface, and this is the function we have defined. Cool. I'm going to go ahead and create our actual cryptodevs.sol, and let's see. Nice. So now we have an interface for our whitelist. Don't forget to save. Now we're going to create one for our actual NFT contract. Let me close this, cryptodevs, and let's get started. So we can copy this from here. This is just the initialization for the version of the solidity we're going to use. And we need to import Open Zeppelin's contract. Okay, so how are we getting this? If you remember, we went to Open Zeppelin, contracts, token, ERC-721 extensions, and then ERC-721 enumerable.sol. So similarly, it's like Open Zeppelin, contracts, token, ERC-721 extensions, and then enumerable.sol, right? So that's how you get it. And we also need to get the Ownable contract. So you go to contracts, you go to access, and then here's the Ownable.sol. So we'll do something very similar. So let's just copy this and contracts, then not token, we need access, and yeah, we need access, and then we need Ownable.sol. So that's how you get the Ownable contract. This is going to help us in the ownership. This is going to help us in creating a contract for the non-fungible token. That's our NFT. And we are going to import the whitelist that we created because we're going to use that as well. So the contract name is going to be crypto devs is ERC-721 Enumerable. So this means that we are importing ERC-721 Enumerable from Open Zeppelin's implementation of ERC-721, and we are also importing Ownable. All right. Then, yeah, the reason it's saying it's abstract is because we haven't implemented all the functions that are needed. So string memory, I'm going to explain what this is, but let's just write some code first. CRI and we also need to do the whitelist. So whitelist is going to be whitelist. All right. So we created the constructor. Okay. So someone is asking, I didn't understand this connection with old whitelist DApp. What did you not exactly understand in this? Can you like explain the question a little bit further, what you're exactly confused on? And I can explain what's going on. But yeah, what essentially we are doing is we had created a whitelist contract in our previous tutorial, and we are basically using the interface of this whitelist contract to to call this whitelisted addresses function, which is going to take an address and it's going to return whether the address is in the whitelist that we created last time. But yeah, if you would like to expand your question, please let me know. All right, so we imported all these contracts, and now what we're doing is we are taking in a base URI. Base URI is just the URL, which is like the base URL for to which when you attach a token ID. So like something like http://learnweb3dao.com is going to be a base URL. /1 is going to be LearnWeb3 DAO /1, where when 1 is the token ID is going to be the URL for that token. But base URL is just going to be https://learnweb3dao.io. So like base URL is the URL, URI is the URL from where you can get the metadata for all the token IDs if you attach a token ID. But it doesn't have to necessarily be a URL. It can also be it can be used with IPFS, it can be used with RWeave. But for our case and simplicity, we'll just assume, because we're going to be like, you'll learn about IPFS in the junior track. But right now, let's just assume it's like the base path. Let's just say like it's a base path to which if you attach the token ID, it gives you the information for that token. And the information is basically all the properties that the NFT has, like the metadata. That's what it is used for. It's like basically the base location. Our constructor also takes in the address of the whitelist contract that we deployed last time. And ERC-721, what it's doing it is that these are the variables that I'm using with my constructor, but ERC-721's constructor also needs some variables, and let's look at what they are. So it needs two things. It needs a name and it needs a symbol. So it needs the name of the NFT collection and it needs a symbol for the NFT collection. So we named it CryptoDevs, and the symbol we just gave it CD. You can give it whatever you want, but that's what it's used for. These are the two constructor variables that it required, and that's why we had to specify it along with the variables that we need in our constructor. This has red line. I don't see a red line in my thing. If your imports are having red lines, it's not a problem. It's just that your settings for the extension, your Solidity extension might have some issues, but you don't have to worry about it. I don't remember how to fix it, but I think if you have to go to Solidity, and yeah, so I think you need to change package default dependencies. So for me, it's just going to be node modules, but you need to make sure that this is the path for the node modules that you are in. Yeah, so if your Hardhat tutorial folder is inside something, you might have to do Hardhat, whatever the name is, tutorial, and then node modules. But for me, it's in my root here. So for me, the root is here. So I don't need this. But if your root doesn't contain node modules, you would have to change the path accordingly to help it find the node modules. But yeah, you don't have to worry about it right now because it doesn't matter. Nothing is wrong with your code. It's just the Solidity extension. Explain interfaces. So interfaces are a way for you to, like, so for example, I wanted to initialize an instance of my whitelist contract. What I did was, to initialize the instance, I wrapped the address of the whitelist contract in the interface, which was of the type iWhitelist.sol. One second. Sorry. One second. Sorry, my phone was ringing. My bad. Okay. Issues you have on when you're live streaming. Never mind. Okay. Um, so iWhitelist is basically an interface for the whitelist contract, and it has all the it is basically creating an instance of the whitelist contract. Um, what an interface is basically a definition. It's a object which wraps in. I know. Sorry. So interface is an object where it's a place where you can put down all the functions that you need to call on your whitelist contract. So like, you can create an interface for any contract you want, and here you would have to write down the definitions of the functions that are there in the contract. So, and that the functions that you actually need. So if you look at other interfaces that OpenZeppelin also has. So OpenZeppelin also has this interface for ERC-721, and what they do is, like, they write down all the events that are there in the ERC-721 contract, like for example owner of. So they basically write the function signature. So what the function is going to take in, the variables, and what it is going to return. So that's what an interface is. It defines the function. It creates, like, it includes all the function signatures essentially on the name of the function, the inputs it's going to take, and the outputs. You don't actually write the code, you just write the function signature / definition, whatever makes you helps you understand it better. But it's mostly the function signature or definition. Okay, nice. So that's what it is. It basically has all the function definitions and signatures and also of that of events. Yeah. So whatever you're going to use, but we are going to use only this function, and that's why you use it here. I hope he understands. Yep. And yeah, so we have this variable called as string base URI. So this is just gonna save the base URI in our variable called as base token URI. I just named it token URI, but yeah, you can name it whatever. And then I created an interface. I gave this interface with the address of my whitelist contract, so that this whitelist contract knows which address do I have to, for which whitelist contract do I have to call. How would it know which whitelist contract it has to call if you don't provide the address, right? You can, so that's why you need to provide the address, and then you have to wrap it in the whitelist interface, and that's how you create an instance of the whitelist interface. And now you can call this function, which is whitelisted addresses, on this instance of the whitelist interface that we created. Okay, nice. All right, let's start writing some functions. So we need start presale, public functions. So we need function presale mint, public, and function mint, right, and what do we need? We need a function for base URI, but yeah, let's just first write a function to start our presale. So presale, so let's create a variable called as presale started, just to keep track of whether our presale started or not. Started, and presale, you just set it to true because you only call this function when the presale has actually started. And this only owner is a modifier from Ownable, and what only owner does is it checks that if the function is called only by the owner. If someone else calls this function, it's going to throw an error and it's not going to allow you. It has to be the owner who calls this function, and that's why what this modifier is used for, and that's why we applied this modifier here, so that we can check that only the owner is able to start the presale. And we also need to keep track of when the presale is going to end. So we said we're going to end the presale in 5 minutes. So public presale ended. So this is going to be a timestamp because we want to end in 5 minutes. So let's just say block dot timestamp plus 5 minutes, right? So whatever the timestamp of my block is right now, add 5 minutes to it, and that's when my presale is going to end. It's pretty simple, right? Like you set this to true and you basically say that my presale is going to end in 5 minutes, which is pretty cool. Simple function. So the next function is presale mint, and this is going to be used for the addresses that were whitelisted to mint an NFT during the presale period. So first you need to check, obviously, that the presale started, right? And you also need to check that my block.timestamp is less than presale ended, right? So it shouldn't, my time should be less than the time when the presale is ending, because otherwise 5 minutes would have already passed, and we don't want that, right? So we just say presale has ended, please don't try to do a presale mint. And we also need to check the sender is in the whitelist, and that's what you do. You have this whitelist instance of whitelist interface that we created, and you have this whitelisted addresses function, and you send the address. So message.sender is the address of the user who is sending this transaction. So you have to check if this address is in the whitelist or not, and this has to be true. Only if it's not true, you're going to throw an error saying you are not in whitelist. Okay, so this person is not in whitelist, and you shouldn't be allowed to do you shouldn't be able to mint, right? Okay, we also need to make sure that our token IDs don't exceed the max number of token IDs. So we decided we're going to only have 20 token IDs, right? So let's just keep a track of token IDs, and we're going to initialize this to 20. And we need to make sure that the number of, we also need to keep track of UN 256, public token IDs. This is going to keep track of the total token IDs that have been minted till now, and this is the max number. So we need to check if the token IDs is less than max token IDs. It has to be max, otherwise max has already been reached and the user should not be allowed to mint any further. And you say exceeded the limit, right? That's how you do it. And we also want to require ask the user to pay a price. Did we decide on what the price is going to be? Okay, we didn't decide the price, but yeah, but like the user has to pay a price for the NFT, right? Like we're not going to give them the NFT out for free. So let's just set a price. Let's just say public underscore price is, I guess, 0.01 Ether. That's how much they have to pay for one NFT. And I have to check that the amount of value that they have sent is greater than equal to my price. Otherwise, Ether sent is not correct. Okay. Yeah, so message.value is the amount of Ether that has been sent by the user. And token IDs, I'm going to increase it because obviously now I'm going to mint an NFT for them, and message.sender, and yep, I'm going to mint token IDs. Yes, token IDs. So what this safe mint is essentially doing is it's minting an NFT to the sender. We can like use uint8. I don't think it matters. We're just using uint256 because yeah, look, it's not going to have any effect on the space. Essentially, if you just have one uint8 variable, and we learned this in senior track why it won't have an effect on uint8 on the space that we're utilizing, because but essentially if you just have one uint8, it doesn't affect it. It has to be multiple uint8s. That's what you save the space. So you can have it as uint8, but it is not going to optimize anything for you. But yeah, you learn this in solid the senior track why one uint8 won't matter. And yeah, but essentially like right now you can do it for sure. It's not gonna really matter. All right. So let's go to ERC-721 and look at this function called as safe mint. So what this safe mint is doing is essentially calling the mint function, but it's checking that like it's taking an to address and it's taking a token ID, and then it's calling this mint function. So what this mint function is doing, it's checking if my to address is not a null address because I don't want to mint to a zero address. It also checks if my token ID already exists. This means that it has already been minted to someone else. Then it increases, it assigns this token ID to this address. So it's like its owners is a mapping. So for this mapping for this given address, the owner is this address, and balances is to keep track of number of NFTs owned by this address. So they increase this balances, and then they emit an event saying that the transfer has happened from address 0, that is null address because this NFT didn't exist before, to this address for this given token ID. Token ID is nothing but a unique identifier for a token, remember that. And before and after the token transfer is essentially calling some other functions, but they aren't really doing anything. You can override these functions if you want to do something before the token transfer or after the token transfer, but we don't want to do anything, so yeah, we are not going to care about it. It also, so after the mint, it also checks on ERC-721 received, and this is basically checking if the NFT was if the NFT was a contract, that it is able to like successfully it's able to successfully send it to the contract. That's what it's checking. Like it's checking that if ERC-721 was received correctly by the contract. But yeah, yeah, and if the contract or if the address is not able to receive the ERC-721, it says that the transfer to a non-ERC-721 receiver. This means that the contract is not able to receive the ERC-721, and it doesn't support being able to have an NFT. So the question is, so UINT 256 or UINT 8 won't impact gas fees? No, not in this case. It won't impact because all our other variables are UINT 256. That's a big misconception. And we learn about this as senior track. The reason I don't want to spend time on this right now is because it's a very big explanation, and we have to go down and look at how storage happens in Solidity, and it's going to take more time than what is required for software mode track. In software mode track, we don't care about optimizations. We only care about being able to implement things. When you go in senior track, you'll learn about optimizations and ways in how you can optimize smart contracts. But right now, you don't have to worry about that. It's a very big concept. You need to understand how storage spaces work in Solidity to understand why it won't have a effect on the gas. All right. Yeah, Solidity is kind of it has so many things going on. Okay. All right. So that's what safe mint is used for. It's used for minting. We looked at how it's done. Now let's do the mint function. So pre-sale mint, again the same condition, but this time we need to check that the pre-sale has actually ended. Last time we were checking that it hasn't ended, but right now for the public mint to start, the pre-sale should have ended. Otherwise, we're going to throw an error that pre-sale has not ended yet. Okay, so that's what we're going to do. Type function. Oh shit! No, this was pre-sale started, not pre-sale mint. Okay. All right. So this thing, and then again this thing we all obviously need. We don't want our token IDs to be greater than max token IDs, And then again, we need this as well. We want the user to be able to send correct amount of ether. We don't need the whitelist check because this is the public mint and this is not the pre-sale mint, so we don't care about that. And again, we just do this. So we just copy it. Pretty simple, right? All right, so we have done the core part of it. We need to write some functions to be able to receive ether. So for example, your function is payable, right? In Solidity, if you want your contract to be able to receive the ether, you need to add certain extra functions, and they are called receive and fallback. You need to write these functions, otherwise your compiler is going to complain that you don't have any functions to be able to receive ether. The difference between receive and fallback is that receive is called when your message.data is empty. This means that you're sending ether, but you're not sending any data. You're just like sending ether just like that. But if your message.data is not empty, then you need this fallback function. So just make sure you have both so that if a user sends in some data, you have this fallback function and you're able to still receive ether. Awesome. So you can also read about this if you go by Solidity by example, and if you look at, I think it was, which one was it? Yeah, send ether. Right. So it explains very nicely how this works. So someone sends an ether, right? And if my message.data is empty, it's not empty, go to fallback. If my message.data is actually empty, go to receive. If receive exists, then go to receive. If receive doesn't exist, go back to fallback again. So if it is empty but receive exists, it's going to go to receive. If it doesn't exist, it goes back to fallback. So I guess you don't need the receive, but it's just a common practice to have both the functions. And yeah, people just include both of them. No harm in that. Awesome. So we also included these functions to be able to receive ether. Okay, nice. Now, one good thing about ERC-721 is that it I'm not able to go here. Okay. I think there's someone identifier. It's showing me. Oh, I wrote a spelling mistake. Never mind. Okay. So ERC-721 essentially has all the functions for you already. So it has all these functions, so you don't have to like implement most of the code. But there's this one function called as base URI. But the only problem with base URI is that it returns an empty string. But we don't want it to return an empty string. We want it to return our base token URI. So that's why we need to change this to be able to be adaptable with what we want to do. So what we're going to do is we're going to copy this and we're going to remove the keyword into virtual, and we're going to overwrite this. So override means that whatever I inherited, I'm going to override this this function. And let me explain this later a little better, but essentially I'm just going to do this. Okay. That's fine. Okay, it's complaining that the name of this function and this variable is the same, but it's fine. We'll just leave it. So what we did was what you can essentially do is for functions which are virtual, they can be overridden by child contracts. So so virtual functions are there so that the child contract or or the contract which inherits ERC-721 is able to override these functions so that the user can have its own implementation of how it wants to return the base URL. So we want to return this variable, but someone else would want to return some other variable, right? So they give you the liberty to return whatever you want. And that's why we use, we override this. All right. I hope you guys understand. Okay. Cool. So that's what it is for. If you remember, I was talking about these functions here before token transfer and after token transfer. These are also virtual functions. You remember I was like, you guys can implement your own implementation. So yes, what you have to do is you basically have to override these functions similar to what I did. I overrided the virtual function, and then you can change these functions. So that's why they give you the liberty to change this and do something before the token transfer or after the token transfer. And that's pretty cool, right? I think it's pretty cool. Okay. All right. Now we need a function to withdraw the ETH from the contract. And again, this should only be withdrawal. Only the owner should be able to withdraw this. So I'm going to take the address of the owner. And event 256 amount 256 amount address this dot balance. This is used to get the balance of the given smart contract, and then we are going to send owner. Actually, let's name this underscore owner dot call value nice. Okay, so what we're doing here is we're using this owner function. If you remember this owner function from the ownable.solve that I was talking about, and it's going to return the owner of the smart contract. By default, this owner is going to be the one who deployed the smart contract, and what it does is it takes in the address of the it takes in the balance of the smart contract. So it does address this dot balance, and then what it does is it takes the owner of the smart contract calls to transfer the ether. So now we're going to transfer the ether to the owner. So to transfer the ether to the owner from the smart contract, you need to say owner.call value and the amount. See, amount is the balance of the smart contract. So whatever ether the smart contract has, you're going to send it to the owner. And this variable is just to check if the send was successful or not. Again, this is a solidity syntax for sending money to an address. So you provide the address, and then you dot call with the amount of ether you want to send, and that's how you send ether from within the smart contract. There are other ways also of doing it. Actually, let me show it to you. Sending ether. Okay, let's see if it has the So we are using this method. The second field is called as the data, but as you would see, I kept that as empty. That's why it has a comma here, because I don't have any data. I don't need to do anything with data, so there's no need for me to declare this. So that's why I kept it empty. But other ways to do it, but as you can see, it's not recommended anymore, is to have an address and then you transfer message.value, but this is not recommended. It's not recommended as because with the higher versions of Solidity, Solidity tries to optimize the things that it's trying to do, right? Like with every version, it tries to optimize the code, and obviously this would be more optimized, and that's why they're recommending you to use this one. And this is the current recommended method to use. This function is also not recommended, so we should not do that, and we'll just be doing this to send ether. This is a very good website for you to stay updated with, what's happening. See, like, it also tells you, like, the whatever these functions are doing. But yeah, so it says that in combination with is the recommended use. So it has the reentrancy guard, and reentrancy guards basically prevents reentrancy attacks, and yeah, we'll learn about that. We'll learn about reentrant attacks in senior track again. And I actually have already written a tutorial on this, and it's going to be pretty cool. You'll learn how reentrancy works, and you'll imitate an attack like reentrancy, and it's going to be super cool. Yeah, so someone is asking, can you set different price for pre-sale and public mint? Yes. So how you would do this is basically you'll have two different variables. So this is going to be public price, right? And then you can have pre-sale price. And let me say the pre-sale price should be 0.02, or actually, I guess it should be less. But okay, and then what you essentially have to do is you have to replace the pre-sale price here, and public price should be here, and that's it. That's how you do it. You have different prices for public and pre-sale now, so user would have to pay public price for this mint to happen, and user would have to pay pre-sale price for this pre-sale mint to happen, and that's it. It's very simple on how you can do it. Yeah, okay, I'm just gonna go back because otherwise people are gonna get confused when they watch this later. All right. So now we can withdraw, which is cool. We're gonna get rich. And yep, we also implement one more function that's called pausing of the contract. So this is something which is very new, and why we do this is because, for example, there's some problem with your contract, right? To prevent someone from like exploiting your contract, you don't want them to keep exploiting your contract. For example, if they already exploited this mint function, you don't want them to keep exploiting this mint function, right? So you want to stop them from minting. And you have this function called as set paused. So what you do is you pause the contract. You say no other functions in my contract can be called when my contract is paused. This is to prevent any attacks, or to prevent like the attack from going further. So for example, someone exploited this. To prevent them from exploiting more, I'm going to pause my contract. So that's what I'm going to do. I'm going to have a variable called as paused, public underscore paused, and this is going to be used for pausing my contract. And for that, I'm going to create a modifier only when not paused, sorry, not paused. And I'm going to require that my contract is not paused underscore this. So paused, I named it this. Okay. Yeah. So I have this modifier, and what I'm going to do is, like, we had this modifier called as only owner, and this was for checking if that only the owner is able to call this contract. Similarly, we created this modifier, and what it does is we're going to apply this to pre-sale mint and to mint, so that only when our contract is not paused, I'm able to mint or do the pre-sale mint. I'm not sure if you guys know about it, but Adidas, when they launched their NFTs, they had to pause their contract because they had some bugs. Apparently, they weren't. They had to give the whitelist to mutant apes, and there was some problems there. So they had to use this pause functionality to pause their contract so that nobody else can mint further until they did something about it, and they included the mutant apes in their whitelist or something. And till then, until they included it, they basically paused the smart contract, and that's what it's used for, pausing the smart contract. All right, I think we are done with our smart contract. We don't need anything else. Yeah, I think we're done. I guess one thing I can do is I can try compiling this and see. I'm not sure if you guys can see it, but I'm basically typing npx hardhat compile. Let's see if my contract gets compiles. Yeah, it's showing me this error. Maybe I can change the name here. Maybe I can keep it base URI. Okay, let's see if it compiles now. Oh, awesome. So yeah, it compiled. If you have any questions, how do you pause? So how do we pause is, we created this function called as set pause, right? So you set the value, the boolean value to true or false, and that's how you set the paused variable. And every time someone calls this, they have to go through this modifier, and it's going to check whether the contract is paused or not, and that's when it allows you to mint. It allows you to mint only when it's not paused. Also, there's this interesting thing. I'm not sure if you guys noticed. This is this underscore semicolon, and what it basically does is that it says that you first execute this require, and then you execute whatever there is in the smart contract. So this underscore basically means whatever there is in the rest of the contract, you can execute that. How do we pause the contract on the fly if we see abuse like you mentioned? There's nothing you can do rather than setting the value to pause. How do we update the code and redeploy? You can't redeploy the code. I think what they did was, I'm not 100% sure, but if I was there, what I would have done is, like, I had this whitelist, right, and I have this whitelist contract. So I would have added the addresses of the mutant ape in my whitelist contract, and then what would have happened is that my require would have now been able to, like, detect if mutant apes were there, and then mutant apes would also be able to do the pre-sale mint, which they were not able to do before. So that's why the use of pause is very helpful, right? Because otherwise, everybody else would have been able to mint, but my mutant apes wouldn't have been able to mint. But I'm not 100% sure what they did. But essentially how you can solve it is by, if you go to our whitelist contract, you first pause this. So you say like, I'm pausing this, and then you use this function called as add address to whitelist, and you add all the addresses to the whitelist which are from mutant apes, and then you unpause it, and then you allow everybody else also to pre-sale mint. And this time it's going to satisfy this require statement, because now mutant apes would also be in the whitelist, and yeah, then you are good to go. I hope that makes sense. That's why pausing functionality sometimes turns out to be useful, and you should always have this. Like, it's very important that your contract is pausable. But again, this is like, it's useful sometimes, but some contracts don't have it. They renounce their ownership, and that is fine too. Like, if your smart contract is well audited, if you're sure of what you're doing. I hope that makes sense. Alright, if you guys have any other questions, let me know. I am going to pause this, like, I'm going to end the live stream in 5 minutes, because I don't want to keep it too long. It's already 1.5 hours, and I know there were some issues with the internet. But we'll learn how to make the app next time, and we'll also deploy this contract next time, and yeah, we should be good to go. And hope you guys enjoyed the session. If you have any questions, I'll be here till, I think, 40. Yeah, 11:40 my time. I don't know what time it is for you guys, but I'll be here for 5 minutes. And if you have any questions, sorry about the live stream today. There was lots of mishappenings with my internet, my voice, and also with my phone ringing. That's what happens when you sleep late at night and are not ready. I hope you guys like it. It's pretty cool how everything is happening in here. NFTs are super cool. If I have time, I'll also show you guys like how we did it. Our contract is also pretty cool, but if I have some time and we don't have any questions, I'll show you this very cool thing. So look at this, right? So I was saying, like, you can have duplicates of NFTs. So what we did was, like, we did something which is like, we did something which we had all the NFTs that were unique. But look at this. Why does it come like 310 owners and 312? These are because these NFTs are duplicated. So obviously we don't want to discriminate between one freshman graduate and another freshman graduate. That's why these are minted as an ERC-1155. And you can see it's like a token standard, right? So if you look at our contract, it's actually executing something called as ERC-1155. And that's what is used for issuing tickets, issuing, like NFTs for like graduations or certifications. And the reason why we do ERC-1155 is because it's gas efficient. It's more gas efficient if you mint NFTs using ERC-1155, and that's why people follow this standard. Let me show you where 1155 is, if I can find it. Here. So see, it says multi-token standard. So if your NFTs, if you have multiple tokens with the same metadata, you use multi-token standard. And if you guys want to read about it, feel free to do the so. I'm going to drop a link here. If you guys want a tutorial on this, let us know, and I'll be happy to host one on ERC-1155s as well, because they are super cool and they are more gas efficient. But yeah, essentially what we did was we used ERC-1155s because we had multiple NFTs with same metadata. Yep, and our freshman graduates and our sophomore graduates, they all have the same NFTs, and that's how you make an ERC-1155. If you want a tutorial on that, let us know on Discord. We can host a live session for that separately, even though it's not there in our sophomore track. All right. If you have any other questions, let me know. We're going to be launching our next set of NFTs March end, I think next week. So if you guys graduate before then, you can get your own NFT, and they look pretty cool, right? Aditya designed it for us, and he's one of our artists, and he designed it for us. And these are one of the best NFTs you can get. They're so pretty. I love everything in here. The colors are really nice, and we're going to be using these in the future for profiles, and yeah, for you to apply for job boards and stuff. So the more NFTs you gather, the higher chances you have for getting a job. So it's going to be cool, because NFTs are going to get added to your resume. We're building something like that, and it's going to be super cool. And then you'll see the use of NFTs. It's not a scam. Trust me, it's not a scam. It has so many use cases, so many that the world can't even imagine right now. Every day, like even the gaming industry, the ticketing industry, everything, like artist industry, everything is changing just based on NFTs. So it's a revolution in itself, and we had the opportunity to learn how to make one is just so amazing, and we are so early in doing so. Half of the world doesn't even know what it is and how to make one, and we learned how to make one today. Brilliance and amazing. Like, it's super amazing to do this every single time. If nobody has any questions, it's 11:40. It was really nice hosting this session today. We'll have the second part, I think, the next week. So I'll see you all there. And if you have any questions, drop them in the Discord. See ya. Take care. Have a really good, amazing night, evening, afternoon, or morning. Take care.